Our project will focus on demonstrating the natural phenomena of free fall, as well as talking about the variables that play a factor into it. During the 2 to 4 minute presentation, we will be defining free fall along with projectile motion and variables such as acceleration, gravity, air resistance, and velocity, which are all mechanisms that are involved in free fall. For the actual demonstration, several tests will be shown, mainly focusing on dropping various objects that differ in size and mass in order to show that any object, regardless of weight, will reach the floor at the same time when under the sole influence of gravity. The other portion of the demonstration will involve throwing objects up in the air, involvement of energy into motion.
Free fall is when an object moves exclusively under the influence of the Earth's gravity. An everyday example would be dropping a ball from arm length. The ball is accelerating down towards the ground as a result of the gravitational force acting on it. This is known as free fall acceleration. If you happen to have thrown the ball up in the air before observing free fall, that portion is called projectile motion, an extension of free fall into the second dimension. It refers to when an object is in the act of kinetic energy decreasing. Today we will be focusing on the behavior of falling objects and diving into how gravity influences their acceleration as well as the projectile motion.
Using data by NASA from the Glenn Research Center with free-falling objects with no air resistance, they provided the knowledge that objects in free fall have the same acceleration regardless of size or shape. Weight is the only force acting on the object. Mass of the object does not affect the motion, shape of the object does not affect the motion, and all objects fall at the same rate in a vacuum.
A higher height will result in a longer fall due to the increased distance the object needs to cover to reach the ground. This will also impact the velocity, as it will result in an increased final velocity. However, as demonstrated, they will still have the same acceleration because the gravitational pull remains the same. Another variable is energy. As mentioned in the introduction, free fall can be seen in the overall motion when throwing a ball upwards and having it come back down. The upwards motion is the part where the kinetic energy decreases while the potential energy increases. Then when the object comes down, the kinetic energy increases and potential energy decreases. Throughout the whole motion, the total energy remains constant. It's only being converted between kinetic and potential.
To conclude our demonstration, we compared the behavior of a softball versus a volleyball under the motion of free fall in order to test out how a difference in size impacts acceleration. We found it to be of no significance as they both reached the ground at the same time. We also tested out projectile motion as an extension of free fall and found that regardless of the initial force, the ball still reached the ground with a constant acceleration of 9.8 meters per second